And welcome back to mechanics, engineering mechanics. Last time I could not take the class on Thursday. I think we'll continue ahead. Based on that schedule, we'll probably add up a class or something. But so in the last class, we talked of concept of moment of a force. Okay. And we also talked this concept. Probably you are all aware. You may have seen it in your high school physics. But so moment of a force, this, as we discussed, any moment is always about a point. We don't talk of a moment unless we talk of a reference point about which moment is taken. And what we introduced in this class yesterday was moment of a force. And you could actually have moment of other quantities also. For example, we have a quantity when we do dynamics, moment of momentum, which you also know as angular momentum. So moment means you take r cross the vector. So if there's a particular vector, there's a particular point, and you want to find moment of the vector about a point A, so then you draw a vector from the point A to the line of action of this vector V. If this is r, then moment about A is equal to r cross V, where V is any vector. So this is how one defines moment of a force. If V happens to be a force, we talk of moment of a force. And as we saw in the last class, moment of a force gives us the turning capability of a force about that point. But then we also introduce the concept of moment about an axis. And this concept is something which you do not see in your high school physics. And briefly to recapitulate, what we did was, if there is an axis, a unit vector along which, so if we have an axis which we denoted by a line L, and there was a force F. So to find moment of the force F about the axis which was given by vector L, what we do is we choose any point O on axis, we calculate moment of the force about point O, and then we take a dot product. So choose O on the axis, then we calculate moment about O, which is equal to r cross F, and then we take a dot product of MO with lambda, where lambda is unit vector along the axis. So this is what we had done in the last class. Now today, let me introduce the last of the concepts which has got to do with the moments, and that is the concept of couple or moment of a couple. Now what we know is, or you may have seen this in your high school also, that two equal and opposite forces not acting along the same line define a couple, let's call C. So suppose we have a rigid body on which a force F1 is acting, and at some other point a force equal to minus F1 is acting. Then the system of opposite forces acting on a body, this is what we call as a couple. Now, what is so special about a couple? If we look at the forces, the two forces are equal and opposite. So if I take a vector sum of these forces, that sum will be 0. So therefore, at least without illustrating, what I can show right now is that on a rigid body, the couple only has a turning effect. If there are two forces acting on a body and they are equal and opposite, they don't act along the same line, then on a rigid body, the net effect of both these forces will be 0. And what this will tend to do is, it will tend to turn the rigid body. So that is the tendency of these two forces. Now we call these forces as a couple. Now let's try to think of this. Let's say this is a force F1, this is a force minus F1. Let us try to find, let's choose some general point O, and let us try to find moment of the couple. Now couple is what? The system of forces F1 and minus F1. We want to find moment of a couple about a point O. So for that, what we do? So we have to take moment due to F1 plus the moment due to minus F1. The sum of these two moments will give us the moment of the couple. So for that, what we do is, let us choose a point A on the line of action of F1, and let us choose a point B on the line of action of minus F1. And now to find the moment, I draw this vector OA, I draw the vector OB. So the moment of the couple will be equal to OA cross F1 plus OB cross minus F1. So this will be the moment of the couple because of these two forces about point O. So this I can write it as OA minus OB cross F1, because we have a cross F1, we have a cross minus F1, so we take it as minus OB cross F1. And what we realize is OA minus OB is nothing but the vector BA. So this is equal to BA cross F1. And what do we realize? What do we see here when we look at BA cross F1? There is no O in the picture. In BA cross F1, that means my O could have been anywhere in space. And the effect of this couple of F1 and minus F1 would have been BA cross F1. And what is BA cross F1? BA cross F1 is nothing but the moment of the force F1 about line of action of a force acting along the other force. So that means what we have is that moment of a couple, and keep in mind couple means equal and opposite forces, is not dependent on the point O. That means it is the same about all points in space. Can we say the same thing for moment of a single force? If I take moment of a single force about a point A, and if I take moment of the same force about point B, the two moments in general will be different. But if I have a couple and I take its moment about any point in space, O1, O2, O3, I will get the same answer. And secondly, this moment can be calculated by placing the origin O on one of the forces of the couple and finding the moment about O of the other force. So what we have shown here is that a couple will produce the same moment about any point in space, and that is why we said that on a rigid body it only has a turning effect, and that turning effect does not depend on which point this couple is acting. As long as the couple has the same moment, it will have the same turning effect on a rigid body. And we can calculate the moment by placing the origin on one of the forces, and all what we need to do is to find the moment of the couple. We will just take the moment about point O, which is on one of the forces, find the moment of due to the minus F about this point, and that will give us the moment of the couple. So now in terms of terminology, moment of a couple is sometimes also called as couple or couple moment. So these are the different terms, and they are used in the same sense, that moment of a couple. Now what is the dimensions of or units of couple? They will be the same as that of moments. So they will be force multiplied by distance. So SI units will be Newton meter. Now because moment of a couple is not dependent on O, it is the same. Couple is also called as a free vector. So this is just a notional definition, that we call it as a free vector because if a rigid body is there, then the couple could be shifted anywhere on the rigid body, it will have the same effect. So having seen moment of a couple, now we move on to the next system, the next concept, a concept of equivalent force system. Now what we mean, firstly let's see what's the meaning of a force system. Force system will mean that we are talking of forces and or couples acting on a given system. So when we talk of a force system, it is implied that couples are also being counted. So for example, let us say I have a rigid body, and on the rigid body I have force F1, a force F2, a force F3, a force F4, and then I have couple C1, couple C2, couple C3, etc. As I discussed in the last class, while both force and couples are vector, because the couple has a turning effect, only a turning effect, we represent it either by a double arrow vector as shown here or by a curved arrow. So let's say we have a system. So this is what is an example of a force system, that on a this thing on a body, given part of a body, forces are acting and couples acting. Now what we want to know is, and the whole crux of our discussion on equivalent force systems is, that force F1 acts at point 1, F2 acts at point 2, etc., and force Fn acts at point n. And similarly we have couple C1, this is acting at some point, let's call it A1, C2 acts at A2, and couple Cn acts at a point An. Actually it turns out, as we have just discussed, where the couple acts, if we are analyzing a rigid body, it does not make a difference, because actually if you think of it, each couple, if it is coming because of two forces, then it could be decomposed. We don't talk of a couple, we talk of a force F and a force minus F, which form that couple, and then the points where they are acting would come into picture. So if we identify in these forces that some of the forces make a couple, then we remove them from the force list and add them to the couples list. So this is how this goes. Now what we are trying to ask is, if all these forces were to act at point O, that means now we are saying the forces in the original system are acting at different points. We want to shift them to a single point. If they were to act at point O, then what would be the force system such that the rigid body undergoes the same motion because of the original system, or because if all the forces were to act at point O. So when we talk of equivalent force system, what we are saying is there are two systems. One is a system where forces are acting at their own this thing, and this is the actual system, couples are acting. Now what we want to do is, on the same body, we choose a particular point A. Now it is up to us which point A we choose. And now what we want to say is, can we find what forces and couple act at A? That means I'm saying there is a single force, let me call it as Fr, R showing the resultant, and a single couple Cr, which I say Cr at A. So can we find what forces and couple, what force, or rather I should say force and couple act at A, such that the two systems behave in the same way? If I can get to that, then I would have got my equivalent force systems. So when we talk of equivalent force systems, we are shifting the forces which are acting on a body to a particular point. Now what do we mean by behave in the same way? I have written here, they behave in the same way. What this means is that the motion caused is same. If the motion caused is same, then we say that they behave in the same way. So to find this, let's just do a very simple exercise. Let us look at a force F, which is acting at a point A. So force F acts at A. Let's look at one by one, and then we will do a cumulative exercise. So a force F acts at a point A, and we want to find if we shift this force to point B. So if we shift this force from point A to point B, then what else should happen? Does the force, can we just say remove the force at A and just shift it to B? Or should it accompany something else? And for that, what let us do is, at point B, let me add two things and I'll do it with a different color. What I do is at point B, let us say I put a force F and I put a force minus F. Am I allowed to do this? On point B, I have put a force F and a force minus F. What is the net resultant of this on point B? Obviously it is 0 because I have put two equal and opposite forces at the same point. So now what we can see is, if I look at these two things together, the force F acting at A and the force minus F acting at B, what does this form? Clearly this forms a couple. And what about the force F acting at B? It is equal to the force F acting at A. So therefore, what this shows to us is that system. So that means we put a force F and a force of minus F at B. Now the force F at B is in vector terms equal to the force F at A, and the force F at A plus minus F at B, they form a couple. So that means from this, what we have shown is that the equivalent of force F acting at A on point B consists of two parts. The first part is the force F itself acting at point B, and secondly we have a couple, and the couple is equal to BA cross F. And if you are getting confused about this, let's again, this is point A, this is point B. At point B I have drawn F and minus F. So this force F acting at B is this part, and these two things, this forms a couple, and the moment of this couple will be equal to BA cross F. So this is how we work out the equivalents. Now what is, in case if we have a couple? So let me go to a new page. What is the equivalent of a couple acting at A on point B? So suppose there is a couple C which is acting at point A. So there's a couple C acting at point A. What is the equivalent of this couple on point B? And I think by now it should be obvious to you that the equivalent of the couple will be nothing but the same couple C. So equivalent of this is equal to the same couple C acting at the point B. Because a couple is a free vector, we can transfer it as it is. I think I should have drawn this C parallel to this, but that is what you should assume. So it just shifts by itself. So now let us generalize. This is, so all the individual forces acting on a body will shift like this. So now let us say, let us show this. So let us consider a system of n discrete forces. This is what we started with, F sub I. That means they are F1, F2, they go up to Fn, and they act at R sub I, R1, R2, up to Rn. That means, I'll just show this on a body, that there is some position vector here. We have a force F1, and this is acting, I'll use another color to illustrate my point. This force F acts at a vector R1. There's a force F2. This acts at a vector R2, and so on. So similarly, the general force here was Fi. This acts at a vector R sub I. And to add to that, and on the system we also have, there are n such forces, and let us say there are m couples Cj, where j goes from 1 to m. That means we have couples C1, C2 up to C sub m. Now, often in a lot of cases, the couples will not act. So this is what we say C1, C2, Cm. So there are these couples which are acting on the system. So this is our original system consisting of n forces, m couples. Now, what we say is the equivalent of the system about a point B would be equal to, the equivalent of this system would consist of two parts. First part would be a force F, let me call it Fr, at point B, and this would be equal to, we shift force F1 to B, we shift force F2 to B. So this is a point B, and here the force F1 plus F2 up to plus Fn. So Fr at B, I can write it using a sigma notation, sum of I going from 1 to n, F sub I. This notation is nothing very big, it's just that we use a capital sigma to show that we are summing quantities. The bottom line shows I is equal to 1, that means we are starting from 1 and we go up to n. So this actually means this is equal to F1 plus F2 and so on up to plus Fn. So the first part of the equivalent at this point B will be a single force Fr, which is equal to sum of all the forces. Now you'll realize that wherever the point B is, that means I could go to a point A, I could go to a point C. The Fr part does not depend on B. Fr part is just a sum of all the forces. So therefore it does not depend on where I am choosing point B. And the second part of this equivalent is a resultant couple at B. Now this resultant couple at point B will consist of two parts. One is it will have a sum of all the couples. How will I write it in the summation notation? Sigma I going from 1 to m couple Cm. So all the original couples which are acting on the system, in addition to the forces, they will as it is come to the point B. Plus, in addition to this, now we had this force F1 acting here. This was at a point 1. So what is the moment of this force about point B? We have to find the couple, because at B we will have a minus F1 acting. So therefore that will be equal to B1 cross F1. So I'll have B1 cross F1 plus B2 cross F2 plus Bn cross Fn. So therefore this I will, when I sum it up, I put it with a summation notation, sigma I going from 1 to n. So at the point B, the net couple which will come will be sum of all the couples plus sum of the moments of all these other forces which are acting on the system, all the forces which are acting about point B. So I take individually sum of all the moments, add them at point B, and that will give me the equivalent of the force system about point B. So now this also gets me to another interesting thing. Suppose I have a given force system and I find the equivalent at A. What would be, so that means initial force system again is something complex. It has all the forces going up to Fn, and there are couples going from C1 to Cm. I find the equivalent at A. What will be the equivalent at A? It will be Fr is equal to sum of all the forces and a Cr at A, which will be equal to sum of all the couples plus sum of Ai cross Fi. This we have already shown. Now, given this, what is the equivalent force system at point B? So there's another point B. I have to find the equivalent force system at point B. Do I need to do all these summations again? Or can I use my result obtained earlier? Well, what we have shown is at point A, we have Fr at A and we have Cr at A. Now, I want to find equivalent at B. I do not need to calculate the summations again. If I have already found the equivalent at point A, the equivalent of force system at point B will be a resultant force Fr, which will be just the same resultant at point A, and a couple which I'll say Cr at B, which is equal to, now whatever is the couple resultant at A, that will, the same value will shift to point B, plus I will get BA cross Fr at A. So if I already know the equivalent about one point and I have to find the equivalent about another point, all I need to do is I need to shift the equivalents of systems from one point to the other. So this is the concept of equivalent force systems. Now maybe what I can do is, if there are some questions at this stage, because then I will move on to some special systems, the coplanar force system and parallel force systems. But before I move on to that, if there are any questions on equivalent force systems, couples, moments about an axis, then maybe I'll take a small break, and if there are any questions, please ask. Otherwise, I will move on. So let's just think about this for a couple of minutes, and otherwise we will shift. We will move on to the next topic. So I'm just waiting. If there are any doubts, how many 27 colleges are there today? So today we have 27 colleges, which seems to be a low number because we were expecting more to join, but I'll just give some more time. If you have any doubts, if there are any queries about this. Now, while I'm waiting for the doubts, let me continue. One thing one should keep in mind is that when we talk of equivalent force systems, then equivalent force systems have a same effect on the body, provided we are talking of the same rigid body. As we will go later on in the course, when we cut a body and we want to find what is the effect of forces on that body, then we have to really talk of the cut body as a system, and then some of these equivalent concepts may not work there, because then we have to look at the equivalent of the forces acting on the cut system itself, not on the entire body. And this confusion often arises when we talk of equivalent force systems. So therefore, uh, we have to, this equivalent analysis is valid when we talk of the entire rigid body and the effect these forces and couple have on a rigid body. Now, as a practical example, do we use this equivalent force system concept in our everyday physics solving problems? Is there an example we can think of where we talk of an equivalent force? Possibly you have been doing this without realizing that you are using the concept of an equivalent force. When we talk of weight of a body, where do you show the weight is acting? All of you, if we are talking of a cylinder, we have to show its weight. If it's a uniform cylinder, what do? We show the weight acting at the center. Do we do that or no? We do that. And or if I can generalize this, we show the weight acting at center of gravity. Now actually, in a cylinder, where does the weight act? Does it act at the center of gravity? Well, if I look at individual parts of the cylinder, then weight is something which is acting, which is an interaction because of the gravitational pull. So it acts at each point on the body. But then why do we show weight acting at center of mass or center of gravity? Well, we do that because we are doing, without thinking, equivalent of the weight is actually, forces are acting at different points on the body. But we can show that it is equivalent to a single force acting at the center of gravity. And we call that as a combined weight of the body. But actually, as you'll realize, weight will act at each point because each point has a mass and its weight will come into picture. So therefore, this concept of equivalent forces we use without actually thinking or knowing that we are using the concept of equivalent force. So now, since questions have not come, let me move on, and we move on to a system of what we call as, there are two special systems. The first system we'll talk of is a coplanar force system. In a coplanar force system, forces on the body are acting in the XY plane. So there is no force acting in the Z direction. We are talking of a two-dimensional body with forces acting only in the XY plane. And if there are any couples, the couples will come because of these forces which are acting in the XY plane. So if there are any couples These arise out of forces in the xy plane. So if the forces are in the xy plane, what is the direction of the couple? And couple means the moment of the couple. So this direction necessarily has to be k or along the z-axis. So that means a force system where forces are acting only in one plane, let us call it as the xy plane, and if there are any couples which are acting, then they are about the k direction. So that is what we call as a coplanar force system. So let us look at it. Let's say this is our plane, this is x, this is y. So we have a force F1 acting here, a force F2, a force F3, and so on. And if there is any couple, then the couple has to be perpendicular to this plane, C1, C2. So they are along the z-axis or my z-axis. So force Fi has got a will be Fx, sorry, force Fi, let me write it again. There are two i's here. Fi will be equal to F sub xi along I plus F sub yi along j. This I represents a particular force. So it could be 1, 2, 3. So F1 will be Fx1 I plus Fy1 j and so on. So let me write this again neatly. Fi is equal to Fxi I plus Fyi j. This is the general form, and any couple C couple is Cj along K. So now if we want to find the equivalent force system at point A, so we want to find the equivalent of a coplanar force system at some point A. So then the resultant force Fr will be sum of Fi, and the couple resultant at point A, this will be equal to sum of Ai cross Fi, I going from 1 to n plus sigma j going from 1 to n couple Cj, the same old formula which we have used. But now Ai will be of the form xi plus yj, and Fi will also be of the form, let's put them in two different brackets, Fi will be of the form Fxi plus Fyj. So now when we take this cross product, I cross I will give me 0, I cross j will give me k, j cross I will give me k. So the net component of CR A which I am going to get from Ai cross Fi will be along the k direction. And similarly, the net component which I am going to get from Cj will be along k, because that is a restriction which I have placed on a coplanar force system. So that means in this coplanar force system, CR at A will be some quantity times k, and we can also write it as CRA scalar times k. Now, so our equivalent at A is equal to some force Fr and CR at A, which is CRA in the k direction. Now, if the resultant force Fr is not equal to 0, then we can move the system to a new point B such that BA crossed with Fr is equal to minus of CR at A. If I move it to a new point B where BA cross FR, now I can always find such a point because this will also be along K direction. CR at A is along K. So therefore, I will be always be able to find point B. Now at this point B, the equivalent force system is equal to part 1 Fr is equal to Fr at A, and part B a couple which is equal to CR at A plus minus CR at A, because that is how we have chosen this. That means this is equal to 0. So therefore, in a coplanar system, we can shift the system to a particular point B where the resultant is a single force. So we can always, in a coplanar force system, shift the resultant to a single point. But this we can do. So we can shift. So this will happen, but this shifting can be done provided the resultant force is not equal to 0. So therefore, what we have is there could be 3 possibilities in a general coplanar system. Possibility 1, Fr is not equal to 0. That means sum of resultant forces is not equal to 0. Then we can shift the system to a point B where resultant is Fr and the couple at that point is equal to 0. That's the first possibility. The second possibility is that resultant force is 0. In that case, we only have a couple CR which is equal to sum of the couples Cj, and in this case we only have if we have just a couple and this CR is the same at all points. Now notice this would happen if all the forces are 0, then either they are acting at the same points or they form couples, because only then you'll have a resultant force coming to be 0. And the third case could be when Fr is equal to 0 and Cr is also equal to 0, and this is what we call as a null system. So these are the 3 possibilities which could arise in the case of a parallel force system. Now what you will realize is that, so that means what we are saying is that if we have parallel forces F1, F2, Fn, let us assume there are no couples right now, that we can shift them to a single point B where the equivalent is just Fr, and Cr at B is equal to 0. Now notice this Fr has a direction. So and Fr can shift anywhere along its direction, along its line of action. So in this terms, the point B is not unique. Actually, it is a line passing through Fr, and all points on this line, the equivalent will be just a single force Fr. So because there are infinite such points, I can always find, if this is x-axis, if this is y-axis, I can find where this point, line of action of Fr, will intersect with the x-axis, or I can find where it intersects with the y-axis. And that would then give me the point where I will say Frx. And just to illustrate this, let us take an example, after which I will end today. For example, if we say we have a body on which F1 is equal to 6I plus 3J newtons, it acts at 8,2, and force F2 is equal to 10J newtons, which acts at 5,3, and we have a couple C1 which is equal to minus 30K Newton meters per act. Now what we want to find out is, find the point where the resultant Fr will intersect the x-axis such that there is no couple there, and we shift it. So to do this, so we have a resultant Fr, we know it will pass through a particular line, so we want to find out where it will intersect the x-axis. So to do this, I'll just write on this only. Firstly, the resultant of this force Fr, this will be equal to, we add these two, it is equal to 6I plus 13J. So the equivalent of this force system is Fr, and what we do is, if it acts at x bar comma 0, then what we do is, let us take moment of the original system about origin. This must be equal to moment of Fr acting at x bar comma 0, and when we do this, this will give us the value of x bar, that is, where does Fr intersect the x-axis. So to do this, let's just work along. F1 x is 6I plus 3J, it acts at 8,2. So the moment about origin of F1, this will be equal to 8I plus 2J crossed with 6I plus 3j. This is the moment due to F1. Then moment about origin of the force F2. Now F2 acts, F2 as I had given was 10j. So it was 10j and it acted at 5,3. So 5 plus 3j cross this thing. And then we have a couple C1 which is equal to minus 30k. So what we will do is we add up all these, calculate these, add these up, and this must be equal to x bar I plus 0j crossed with fr. So this will be x bar I plus 0j crossed with fr, and fr was the resultant sum, that was 6i plus 13j. And when we solve this, we get the value of x bar. And this is how we solve, where to find where does the equivalent force act. And you will realize in this problem, had C1 acted or not acted, the value of x bar changes. So the role of the couple C1 is to redistribute where the equivalent force acts. So this is for a planar force system. In the next class, I will look at parallel force systems. I'm here for some time in case if there are any doubts, any questions you want to ask, because I had given time for interaction and I was a bit discouraged that nobody asked anything. Maybe things were clear or they were not at all clear or totally clear. It could be one of the two things when people don't ask questions. I hope it was the former and not the latter. But still, if there is anything you would like to ask, you could please communicate to us. I hope the communication link is working. It is okay. So please ask your questions, any doubts you have. I'm here for at least next 2-3 minutes. So at least convey to us, and I can wait longer in case you have doubts. I would actually like to see some of the classes, maybe. So put 1 or 2 classes. Why don't you do that? So put up one of the classes. At least let me see who are the people who are listening to these lectures. Let's let's have a look at some classes. Somebody there, or am I talking to a blank audience? Maybe next class onwards, after half an hour, we'll just look at some classes so that we know. Yeah, can you hear me, please? Which college is it? Let's connect to someone. RGI TKL. Are the students there? Are you there? But if you have, at least I can see only your head, part of your forehead. I can't see your face. I can't see the class. Maybe we can try. I think the camera there is not focused correctly. Some other college. Yeah. Okay. Which place is this? PCE. Can I have some feedback from the students, please? Are you understanding what I am teaching? Bacha, please, some student, what happened? Got cut or what? So can please somebody, I just want to have an informal feedback. Our class is over. Are you understanding what I taught to you? Can
Hello,
one of the
can you hear
students
me,
come
sir?
up, please?
Hello.
Hello, yeah. I would like to talk to one of the students, please.
Hello.
Yes, hello. Yeah, please. What is your name? Yeah, can you speak, please? I can't hear you. Hello, yeah, please take the mic closer to your face. Yeah, what is your name? Acha. Did you find the lecture useful?
Yes, sir.
Is the pace okay or is it too fast?
It was okay.
It was okay.
Some
Were
of
you able to follow what I was teaching?
yes, sir. Couple of forces.
Yeah. Were you able to understand what I taught?
Yes, sir.
Okay. Now also what I would like to know is you're in the first year of undergraduate college, or what are you what is the level of your
The first year.
first year of college? Second semester, civil engineering,
No, sir, electronics and communication.
electronics. But have you seen these topics before, or are you seeing them for the first time?
Some of the topics and some of the terms were seen before, but no, some are unknown.
But okay, but is the level too low, or is it okay, or is it too high?
It was okay, average.
It was okay. So I have also prescribed the textbook I have written. It's vector mechanics. Maybe you can, or you can even go look at any book of mechanics. Please try to read up what I am doing before you come for the next class, so that then these things will become more useful. And right now I am going at a very sort of preliminary level, but after a couple of classes we will move on to probably more levels and new concepts will come in. Okay, thank you very much.
Thank you.
I think. Thanks. So next class I will try to have some more interaction with more colleges. Thank you. And please feel free to ask. I will give you time. Just send a query here. They will tell me and I'll try to respond. It's good to get some feedback, because a single monologue is not very useful. Then I could have just sent a video cassette or a CD or a DVD. But okay. Thank you very much.